Alright guys, ellipses. That's what we got next. You know what? Something just doesn't feel right. Alright guys, that's more like it. Alright, let's talk about ellipses now. So, very first example I want to do today, we're going to try to find the center, vertices, foci, and graph this ellipse. Now, from what we saw about ellipses the other day, this is not the format of the standard equation of an ellipse. This looks way wrong, basically. So remember the standard format was we had like x minus h, the quantity squared, y minus k, the quantity squared. Those were both over something and added together, and then equaled 1 on the other side. This doesn't look much like that right now. So our goal here is going to be make this look like that. Put this into the standard equation of an ellipse. So to do this, we're going to use the process we did the other day where we complete the square. The difference is when we completed the square with parabolas, we had to complete the square with one variable because we only had x's squared or only had y squared. In an ellipse, x and y are both squared. So we're actually going to have to complete the square with the x's and complete the square with the y's. So let's get to it. Now first off, we need to make sure the leading coefficient on these is 1. And we need to make sure that all the x's are kind of beside each other and all the y's are beside each other. And then anything that doesn't have an x or y, any constant, we're just going to get out of the way basically by moving it to the other side. And so I'm going to rearrange the terms here. Basically, I'm not doing any algebra yet as far as like completing the square. I'm just putting things in order beside each other. And so I'm going to call that 4x plus 8x, just put those beside each other, plus 3y squared minus 6y, put the y's beside each other. And then this negative 5, I'm going to move to the other side, which would be a positive 5 when I add 5 to both sides. So, to complete the square, this is something that you probably haven't talked about a lot before with completing the square because it didn't really come up in a lot of other examples yet, but you notice the leading coefficient here in front of the x squared is a 4 and not a 1. In order to do the 1/2 b, the quantity squared thing, to find the number we have to add, that leading coefficient needs to be a 1. So to make it a 1, here's what we do. We're going to factor out a 4 just from the x's. So I'm going to factor out a 4 right there, which leaves me just an x squared. And since I factored out a 4 from 8x, 8 divided by 4 gives me 2. So I've got plus 2x there. Now we've already mentioned we're going to complete the square. So here's what I'm going to do. I'm going to leave myself a little blank there in order to put the right number in, complete the square and the x's in just a second. Now let's do the same thing over here with the y's. The leading coefficient on the y squared needs to be a 1. Right now it's a 3. So what I'm going to do to solve that is I'm going to factor the 3 out of both the y terms. So I'm going to bring out a 3, which leaves that first one that was 3y squared is just y squared. The minus 6y, negative 6 divided by 3 is negative 2. So that makes that a minus 2y. And again, I'm just going to leave a blank and then equals 5 there. All right, so let's try to complete the square now. And remember, our big trick for completing the square was we need to add 1/2 the b term squared. 1/2 the b term squared. And so our b term is, remember, it's ax squared plus bx plus c. Our b term is always like the linear term, the one that's just on just x, just y, not the squared and not the constant over here. And so if I need to add 1/2 of b squared here, b is 2, half that's 1, squared is still 1, so I need to do a plus 1 there. Now here's where things get confusing and where I have people who run into problems quite often on this part. I added 1 here. We talked about this the other day. You can't go randomly adding numbers into an equation because it's no longer equal if you do. But it is equal as long as I do it to both sides. So if I add a 1 here, I've got to also add something to the other side. Now here's the thing. I put plus 1 here. I'm actually going to put plus 4 over here. Now that might sound like I'm just making things up, but do you notice this plus 1? There's a 4 factored out, which means this plus 1 actually added 1 times 4 to this side, which means by putting a plus 1 there, I actually added 1 times 4, or 4 to this side. And so here, I'll write it like this to maybe make it even a little easier to see. What I actually added there was Even though it says plus 1, I added 4 times 1. And then let's do the same thing on this. Half of b, so our b term is negative 2. Half of negative 2 is negative 1. Squared is positive 1. So I need to do a plus 1 on this side as well. Now over here, let's think about what I need to add. I know it says plus 1, but there's a 3 factored out in front of that, which means even though I put a plus 1, I actually added 3 by putting that. And so what I'm actually adding is 3 times 1. So let's try to do some simplifying now. We've got a fairly long equation here now, so let's try to work this down just a little bit. This factors. I need things that multiply to 1 and add up to 2. That's plus 1 and plus 1. And remember, the whole point of this was to make this factor as the same thing twice. So it's 4 times the quantity x plus 1 squared. This factors as x plus 1, which is x plus 1, the quantity squared. Plus 3, let's see how this one factors. We need to have numbers that multiply to 1 that add up to negative 2. Well, that would be negative 1 and negative 1. And so this is 3 times y minus 1 twice, but y minus 1 times another y minus 1 is y minus 1, the quantity squared. And then let's work with this bunch of numbers we have over here. We have 5 plus 4 is really what this turns into, plus 3. And so in the end, we have 5 plus 4 is 9 plus 3, so we've got 12 over there. Now here's a big thing. In the standard equation of an ellipse we just learned, the right-hand side needs to be 1. The right-hand side here is not 1, it's 12. The easy way to make it a 1 is just divide both sides by 12. So basically when you get to this point, whatever this number is over here, divide both sides by that number. So I'm going to divide this side by 12, that's going to make that a 1. And I'm going to divide this side by 12. Now a big thing when we do this, it's not just this part divided by 12 or this part divided by 12. If we're dividing the whole thing by 12, then we could just put that under each part individually. And then I just need to do some stuff to simplify these fractions here. 4 over 12 is really the fraction we have going on here. 4 over 12 is 1 over 3. And so that makes this really say x plus 1, the quantity squared, over 3. Because the 4 over 12 just became a 1 over 3. And the 1 out in front, I don't really have to write it. Multiplying by 1 doesn't do anything. Plus, we have 3 times quantity y minus 1 squared, but 3 over 12, if you simplify it 3 over 12, you get 1/4. And so again, the 1 out in front, you don't really have to write it. It doesn't do anything. So I have y minus 1, the quantity squared, over 4, because 3 over 12 became 1 over 4. And then equals 1. So now we've got this thing in the standard form of an ellipse. And remember, this is h and k beside the x and y. That's going to tell us where the center is. So we're going to see if we can graph this thing and figure out all the important information we need to based on this. So I tell you what, I'm going to try to put all the important information up here, and then we're going to draw a graph down here. So some things that we know. Center. Well, h and k represent the center, but remember it's minus in the standard equation. And so x plus 1 means negative 1 for the x-coordinate. Y minus 1 means positive 1 for the y-coordinate. So the center is negative 1, 1. To get to the vertices, alright, I'm going to start to draw a picture because I think that would be helpful here. So I'm going to go down here where I have just a little bit more room to draw this. Alright, and so if I want to draw this graph, first thing I'm going to do is just plot that center point, because I think that would be a helpful thing to see on here. And then I'm going to see if we can figure out which way we want to go to the vertices. So we've got negative 1, 1. There's our center. Now think for a second. Should I go up and down to get to the vertices, or should I go left and right to get to the vertices? So since we're going y, under the y is the bigger number, we're going to have to go up and down to get to the vertices. This has a vertical major axis, basically. So remember, it's just whichever one has a bigger number under that, that's the way the ellipse is stretched out more. So this is bigger number under the y, stretched out more vertically. And so this is a squared. So if a squared is 4, that means a is 2. And so for the vertices, I'm going to have to go up and down 2 units. So I'm going to go up 2 units, down 1, 2 units. There's the vertices. And so the coordinates here are at -1, 3. And then the other one is at -1, -1. So there's the coordinates of the vertices. We also need to figure out how far to go left and right to make this thing open the right amount. So we need to find what we call a co-vertices. I know that's not on our list here, but it's helpful in drawing the picture, so I'm going to go ahead and find these. Now, some things we know about co-vertices. They're based on b. B squared in this is 3. Remember, b is just the smaller number of the two. B squared and a squared are under here. B squared is the smaller, so that's 3. So if b squared is 3, then b is the square root of 3. Doesn't work out to as nice of a number here. It's about 1.73. We'll use that when we draw the picture. And so the way I could say this, I want to go from the center, left and right, the square root of 3. But we're not starting at 0, we're starting at the center point. So we're starting at -1 for the x, and from -1 we're going left the square root of 3 and right the square root of 3. So here's a way we could say that. -1 plus and minus the square root of 3 gives us the x-coordinate of the co-vertices. And then the y-coordinate, if I'm just going directly left and right from here, the y-coordinate doesn't change, so it's still 1 like it was at the center. And so to graph these, since the square root of 3 is about 1.73, I'm going to go about 1 3/4 is what I'm estimating this with here when I'm drawing this out. So I'm trying to do about 1 3/4 left and right. It's just slightly under 1 3/4, but it'll be, as far as graphing is concerned, that's a good estimate to use. All right, so our ellipse or something like it looks something like that. My drawing skills on ellipses are not perfect. All right, and so there's what our ellipse looks like, something like that. And then the only other thing that I think we should find here is we need to find the foci. That was part of the original question. Now to find the foci, something we're going to need to use, remember the relationship between A, B, and C in an ellipse. We said that b squared plus c squared equals a squared. We know that, we know that, we don't know that, and that's what we need for the foci. So b squared is, and I'm just going to go ahead and do this. Do you notice we have a squared and b squared here? B was the square root of 3, but b squared was just 3. So I have 3 plus c squared equals a squared. A squared is 4. And so subtracting the 3 to the other side, I get c squared is 1, which means c is the square root of 1, which is still 1. All right, so this is what that means. C, remember, is distance from center to focus. So that means to get from the center to the focus, I need to go up and down 1. And remember, the reason I know I need to go up and down is because this has a vertical major axis, and the foci always lie on the major axis. And so to find these coordinates, I'm going to go over -1 to -1, then I'm going to go up 1 from there, which puts me at 2. And then I'm going to go over and down 1 from there, and so that's -1 for the x, and down 1 puts me at 0 for the y. And so there's the coordinates to the center, vertices, co-vertices, which wasn't asked for but helpful for the graph, and then the foci as well. All right, is that making sense how we got that? So just to run through a couple key points of this, because I feel like there's a lot involved in this one problem. We have to get, at the beginning, all the x's together, all the y's together, then all the constants out of the way on the other side. Factor out any leading terms on the x squared and the y squared, get those factored out so that we can complete the square. And then to complete the square, we do the adding 1/2 b squared thing. And remember, b is just this term on just the x or just the y, not the squared one. And then once we have that number, we add it to this side, and we add it to this side, remembering that when I put +1 over there, it's really 1 times 4. So that's why we added 1 times 4. When I put a +1, it's 1 times 3, 1 times 3. And then, in order to make the right-hand side 1, like the standard equation, divide both sides by that number. So I know there's a lot there, but it's kind of a synopsis of what we did there. All right, so this will give you a good start on this. And then we're going to do another example in just a minute where we do some things with figuring out why this thing works. but I'm going to stop there for right now.